When John Behrman called and invited me up here, this is indeed the first time that I've appeared in public without the shield of the newsprint around me, since I agreed to the ridiculous job of writing about computers in a daily newspaper. And John Behrman called and he said, we'd like you to introduce the people who are going to be doing the demonstrations for Windows NT and OS2, and he likened it to a World Wrestling Federation match. So the people down in front, you may be splattered with blood by the end of this, but it should be very interesting. This is indeed, as John said, this is history here. When the next century dawns, you may not actually have Windows NT or OS2 specifically on your machine, but it's going to be something like it, because 32-bit operating system, I know they want it exactly to be Windows NT and OS2. But it's going to be 32 or 64 or 120. I mean, it's only going to get bigger. It's only going to get more powerful, and it's only going to get friendlier. The interesting thing is what has happened here has changed these companies. At Comdex, you had Bill Gates in a suit, and you had Jim Canavino in a red sports shirt. And I noticed tonight the Microsoft guys are in suits and ties, and the guy who's going to demonstrate OS2 is in a red sports shirt. Anytime you can get IBM out of those white shirts. At any rate, this is an important night, and this is a glimpse into the future. And watch very carefully, because I know some of you people here are going to be making decisions as to what kind of, as to which way you're going to go. And you're going to launch your company off on a direction that is toward the 21st century. The first person tonight who won the coin toss and who will be going to the mat first is Doug Davis of Microsoft. He'll be demonstrating Windows NT. And we have with IBM Dave Barnes, looking natty in maroon over here. And sit back, relax, and enjoy it, as Clayton Williams said. And I'm sure that this is going to be a lot of fun. Thank you.
Yeah, at least I don't have a blue suit on. That's one thing good about it. My name is Doug Davis. I've been with Microsoft for the last 3 years now. I used to sell OS2. Now I sell Windows and Windows NT. We're going to talk about, start off the presentation. I'm going to talk about what's going on with Windows NT, where it is today. Hopefully we'll get down in some of the architectural aspects of Windows NT. You'll see why we feel it's a superior product to other operating systems on the market. And last, we'll get into a demo. I can't see many hands, but I can see a lot of them. How many people are out there running Windows 3.1 or Windows today? A lot of people. Okay, how many people got their Bill Gates wedding invitation?
Don't poll the audience.
Okay, I won't. But I've broken a rule already, I'm sorry. Last Monday, the 24th, Bill Gates announced Windows NT at Comdex. It was a very low-key announcement. It was simulcast to about 50 cities. For Microsoft anyway, that's a pretty big event. And the presentation he did was very low-key. It wasn't a lot of glitz, wasn't any dancers, any songs sung or anything like that. But the purpose of the presentation was to show the power of NT and show that the market has been needing something like that. I know you've probably seen this article in some of the trade rags recently. NT, fortunately, has generated a lot of interest, even though it was an unannounced product. So a lot of our competitors had started positioning against NT before the release, and this article has been running for quite a while. They're not their only competitor, though, that's got NT in mind. Sun is also, with their Sun Select product, focuses on NT. A lot of people are giving Microsoft credit for bringing the rest of the industry together to create some standards. I don't know whether that's out of fear, survival, I'm not sure. One person or one company just can't deliver an operating system and make it successful. It has to be a combination of a lot of things. You have to depend on software developers. You have to have solution providers or people who deliver solutions in large corporate customers. Of course, you have to have a company there that has the vision to do it. And you also have to have hardware vendors. And they all have to work together. And we kind of feel that Windows NT makes all the puzzles fit together, puzzle pieces fit together. From a Microsoft's perspective, you'll see a lot of things in the press about where NT is positioned. But from just a marketing standpoint and where we feel it's going, essentially we feel it's the most powerful client-server desktop or server on the market today. On the market. That's an announced product. We'll get to that. It's only one piece of a family, though. I mean, there were a lot of people that are running Windows 3.1 today. A lot of people still use DOS. But essentially, Windows NT fills out a family of operating systems. We start off with the low end. You can run Windows today on pen systems, laptop systems. As we move up the chain of hardware, you see we go to Intel-based workstations. That evolves to RISC-based workstations, and eventually symmetric multiprocessing super servers. And the intention from Microsoft is to have an operating system that runs on all of those environments, so that from a user perspective, from a development perspective, you have a common interface, you have a common API set, and you have all the common things that make it easy to develop and deliver on any of those platforms. Now, let's talk about the Windows NT architecture. It was designed by David Cutler, essentially. David Cutler was the father or chief architect for VMS for DEC. And when he came to Microsoft in 1988, his mission was to build the most powerful PC operating system. Now, that was OS/2 when he came, and a lot of people forget that when we first went into this project, the whole operating system as it existed today was OS/2 3.0. And I can pull back slides from way back then and see that the same feature set that's in Windows NT today was an OS/2 3.0 feature set. But essentially, it's a modular and layered architecture. We'll go into a little more detail on that. It's client-server in its implementation, and you'll see how that applies in a second, too. It's portable. Very important as we move through enterprise architectures and get into new advances in chip technologies, that you're able to port your operating system easy as hardware vendors come up with new technologies. When Windows NT will be released, it will run on the Intel 386, 46 Pentium architectures. It will also run on the MIPS R4000 family of processors and the DEC Alpha family of processors. So NT will be an operating system that spans multiple processors. And it's also was designed from the ground up to be symmetric multiprocessing. And essentially what that is for the user is the ability to throw in a new processor into their machine and get linear performance increases, so that if I determine that I'm CPU bound, if my machine supports it, I put another processor in that machine, and lo and behold, my machine gets faster. Now, this is real important when I'm talking about large computing and enterprise environments where I need scalability, to where I can deliver a solution, and then as I outgrow that solution, I don't necessarily, my system is not outgrown. I add processors and memory to it. Now, as a base component of the NT architecture are protected subsystems. Now, there's two different types of protected subsystems in NT. One of those is environmental subsystems. And that's where we have the Windows 32 programming environment. We have the DOS programming environment, to where you can run DOS applications. You can also run Windows 16-bit applications. You can run POSIX 1-based applications. You can also run character-based OS2 character-based applications, and those are the OS2 16-bit applications. Now, the purpose of the OS2 subsystem is essentially to give users the ability to, or time, so that they can take their OS2 server-based applications and move those to NT over time. What we found in a lot of OS2 development was server-based, and there were a lot of client-server applications developed under OS2. So we needed a subsystem that would allow the users to move and migrate to a high-end operating system. And the last one is integral security. Security is very important to the base product, and it's essentially not something that was bolted in or architected in. It was architected from the ground up to be C2 secure, and what that is a government specification that sets a security level. Now here's a graphical view of the NT architecture, and let me just take it from across the top. You have your OS2 16-bit applications, you have your POSIX applications, the Windows 32, MS-DOS, and Windows 16, and these all run in what's referred to as user mode. There are two modes that NT use. I know a lot of people have ever heard of Ring 0 versus Ring 3. For example, that architecture doesn't exist in RISC-based processors. Everything is divided into two pieces, either user mode or the kernel or privilege mode. Well, all the subsystems and applications run in what's referred to as the user mode. And as we move down the kernel side of things, we can see that the hardware is at the very bottom. We have this little piece of code here called HAL. Good choice. I know it really wasn't meant to be that, but it's referred to as the hardware abstraction layer. And what that does is it isolates NT from any hardware-specific components. For example, there's no standard today in the PC industry on delivering multiprocessing machines. If you talk to AST, Compaq, Dell, Wise, all these people that are delivering multiprocessing systems, they're not designing them exactly the same. It's not the golden age of PC compatibility that we once realized. So we needed a software isolation layer that we could isolate those machines from the operating system and run NT on those very seamlessly, and that's where the hardware abstraction layer came from. The kernel, the big piece down here, the kernel in NT is only 40K, believe it or not. The use of memory in NT is mainly to run the protected mode subsystems and some of the other caching mechanisms. But the kernel is very small, referred to as a microkernel. You have different subsystems on top, or different object layers on top of that. I'm not going to go into detail on each one of them, but we have caches and a process manager, and essentially the I/O systems and the network device drivers. The system itself contains about 4 million lines of code. The kernel itself, I said, is 40K. 95% of it is written in C, and only 5% of it is written in assembler. That makes it extremely easy to port to different architectures. Now, we talked about symmetric multiprocessing and what that means. Well, I'm going to look at, this is a sample application. You could have pulled this out of any Unix vendor's symmetric multiprocessing. That's really where symmetric multiprocessing started. But you have a process that is essentially bound to each CPU in the machine. And that can be very high performance, but there are some problems with it. First of all, everybody communicates through the shared memory, which is not the most efficient way to do it. The application essentially has to play operating system. It has to understand when things are coming into focus, coming out of focus. And there's a lot of overhead that people have to build into their applications to make them multiprocessing aware. Well, with Windows NT, we can take a different approach. And let's just talk about one of the products from Microsoft, and that's SQL Server for NT. In that thing, we have, in that program, we only have essentially one process, and we break them into multiple threads or smaller processes. And we let the operating system handle the scheduling of those processes across the different CPUs. That's a lot more efficient. We let the operating system handle it. There's not a lot of complexity that we have to build into our code. It's essentially all handled by the operating system. Now, we feel that NT is a powerful platform for building solutions. Now, it's a reliable architecture. A poorly behaved application cannot crash the system. We talked about how the application and their subsystems run the user mode. At no time does an application in Windows NT link into any system memory, something that other operating systems will let you do. That can't happen in Windows NT, so an application cannot crash the system. We have desynchronized input queues. This is very important. It sounds very technical, but what essentially it means is that I'm not limited by whatever task I'm doing to go do another operation. Right now in OS 2 and Windows, if I clicked on the file manager to do a drive search, I wait to do a drive search because essentially the system is processing input. Windows and OS 2 today share what's referred to as a single message queue. And what that means is that all the messages that are passed through the system pass through one place. In NT, every application has their own unique queue, so that cannot happen. We talked about security a little bit. It's integrated into the system. It was architected in. And we have UPS support that's built into the product. And last, we support asynchronous I/O, which is a really high-speed way of writing code. The file system in NT is new. We had to develop a new file system for one reason, that being that to be secure and to be a government-level security, the file systems that are out there today don't support the kind of access control structures that you need for a high-end operating system. We'll support very large disk and files. I think they've calculated that NT will support volumes up to 184 terabytes. Now, that's volume size, and you can have multiple volumes in the system. So I don't think we're going to be running out of file size limitations for a long time. We have long file names, and we also auto-generate 8.3 names, which is very useful if you have users that are accessing NT as a server. If they're on a DOS machine, they see their old 8.3 name, you can still use a long file name, and the file names are linked together. We have Unicode support, which is very important for international market. We do transaction logging for quick recovery. What this does is if the file system ever goes down, you have to reboot. Today, you essentially wait on check disk to check your file system to see if it's okay. Well, imagine running check disk on 184 terabyte volume size. We would be here for a very, very long time waiting on that to complete. So with transaction recording of the processes that take place in the file system, we can recover very large volumes in seconds instead of hours. And last, the file system itself is built for 64-bit access. All file offsets are 64-bit. So that's why we get such a large size out of the file system. Now it preserves your existing investment in MS-DOS applications. You can run your MS-DOS applications as they exist today. You can run multiple MS-DOS applications. We'll show you that during the demo. Anything that's MS-DOS 5 compatible will operate in this environment. You can do full screen or window text. It's up to you, just like in Windows. And you can also copy and paste to the clipboard. Very seamless. You can preserve your investment in Windows applications by running your existing 16-bit applications. Essentially, you can copy, paste, DDE, OLE between 16-bit and 32-bit applications. The Windows 3.1 apps run as they're designed to, and that's to run in the same memory address. Windows NT applications are 32-bit applications run in a separate memory address. Windows 16-bit applications run in a single address space. Performance is comparable to Windows 3.1. User will not notice the difference between running a Windows application under NT or running it under Windows 3.1. And last, it's binary compatible. You can run your Windows 16-bit applications on either the Intel platforms or any of the RISC-based platforms. Yes. Yes, enhanced mode. 32-bit applications for Windows NT and Windows 3.1. As part of the Developers Conference last July, we released a specification known as Windows 32S, which is a subset of the Windows 32-bit API set. Today, under Windows NT, you can run a Windows 32-bit S application under Windows NT as a native 32-bit application, or run it as a 16-bit or 32-bit application under Windows 16. And the way this is accomplished is through running virtual device drivers on top of Windows 3.1. That's something that OS 2 cannot do today. Windows NT has built-in 3.1 has built-in networking. Essentially, in a base NT box, you have an unlimited file and print server. It'll support an unlimited number of user connections, however many you feel that you will let on your machine in a networked environment. It's protocol independent. You can run IPX, TCP/IP, NetBEUI, OSI, any protocol you select. The three protocols in the product will be a NetBEUI or a NetBIOS-based protocol, TCP/IP, and DLC are the data link control protocol used to do 3270 access. It's a superset of Workgroup for Windows. I know a lot of you were here probably in February, I guess it was, when we did the demo of Windows for Workgroup. It has the same features, NetDDE, chat, all that's built into it, file and printer, easy file and printer sharing for the user, and the Mail and Schedule Plus as applications are also built into the system. We have an OSF DCE compatible RPC. Now that's a lot of letters. Let me tell you what that means. OSF is a body working on delivering of an operating system. They have a remote procedure call mechanism which allows two machines to talk to each other, and it's referred to as a remote procedure call. All of the remote procedure calls in NT are DCE compliant. What that really means is that from another DCE environment, whatever that might be, to an NT environment, we can share information or connect to databases or write distributed applications. It's network independent and it's protocol independent, and really simplifies your development. Now, as far as connectivity to Unix environments, we support POSIX.1, which is it's a government programming standard. We do X Windows emulation. This was demonstrated at Windows World last month. We also support Windows sockets and RPC mechanisms. As far as network integration, I stated already that TCP/IP is included in the box. We have an SVR4 compatible streams environment, and NFS, our network file system, as it's referred to, is also available from NT from a third party. Now, Windows NT was built more for just end users. It was built for manageability, very important in large computing environments. We'll support both NetView and SNMP, which are mainframe or Unix-based consoles to do network management right out of the box. We have utilities in NT that are already meant for remote management. For example, as a remote administrator, I can change the configuration of an NT machine. I can limit a user's options on an NT machine to where they can't change its configuration. I can monitor its performance. I can do remote backups. Everything that I would think of doing at the desktop as a LAN administrator or network operator, I can do remotely now using Windows NT. I already said we support NetView and SNMP. As far as NetView reporting, you can map any NT-generated event, which is anything that happens in the system, can generate a NetView alert, so that from a host-based system, you can submit commands to NT systems or take alerts to NT systems. As far as SNMP, we'll support the standard architectures for MIB1 and MIB2, and it's all extensible. Now, there's a separate product from the base product for NT, and it's referred to as NT Advanced Services. We have centralized administration, so that you have one user account and log on throughout your enterprise. We have a remote access server that's included in the product. This gives you the ability to dial up asynchronously and connect to an NT machine as if you were connected to the network. We support Macintoshes as clients for this environment. And we've also added enhanced fault tolerance in this product. We'll support file replication, disk mirroring, disk duplexing, and RAID 5 in software. So there's no need to buy specialized hardware to do things like disk striping and disk striping with parity. That can all be done in software now in NT. As far as pricing goes on NT, The NT full package product is $495. Upgrade from DOS or Windows or OS2 is $295. The advanced server product, now there's some things to consider here, like having an unlimited file and print server. Roll Windows and Novell into one box and essentially try to figure out what that would cost. Windows NT Advanced Server product is $29.95, and an introductory price right now is $14.95, and of course the upgrade from the LAN manager is $5.95.